Today, we're going to talk about the interaction between gravity and inertia. Our learning targets for today are I will explain the interaction of gravity and inertia and how it controls the objects in the solar system. I will describe gravity as the force that keeps planets in orbit around the sun and governs the rest of the motion in the solar system. So, what is gravity? Gravity is a force that attracts objects to one another. It is a pulling force. Okay, so if you look at this picture, that's how you see that there are people on the other side of the world. So to us, they're upside down. Now to them, they're right side up. But gravity is what's holding them and pulling them to Earth's surface. Gravitational pull depends on two things: mass and distance. If the mass of an object increases, then the pull of gravity increases, right? If something's bigger, it's going to have a greater pull of gravity. If distance increases, that means if you're further away, then gravity is going to decrease. Okay, that pulling force is not as strong if you're really far away. So, then we're going to look at the laws of motion. Sir Isaac Newton developed the laws of motion. The laws describe the relationship between a body or an object and the forces acting upon it and its motion in response to those forces. So think about it. If I pushed you, right? We're going to be looking at the relationship between the force of me pushing on your body and what your body does in response to me pushing you. I would never push you. So, Newton's laws of motion. His first law is the one that we're going to talk about and describe the relationship with gravity, is the law of inertia. The second law is the law of force and acceleration. And the third law is law of action and reaction. But we are going to focus on the law of inertia. Well, we defined gravity. We need to define inertia. Inertia is the tendency of things to resist changes in motion. Okay? When we say resist changes in motion, think about someone who pulls tablecloths from underneath plates. Okay, those plates resisted change in motion. An elephant has more inertia than a human. So what does that mean? It means that it's harder to change an elephant's motion than a human's motion. If the man in the picture tries to push the elephant, it is very unlikely that the elephant will move just from the force of the human. Now, if the elephant pushes the human, it is very likely that the human will fall over because the elephant has more inertia than the human. So let's look more at Newton's first law, the law of inertia. This law states that an object at rest, meaning it's not moving, will remain at rest unless acted upon by an outside force. Right now, if you have a book beside you on the table, it's not moving. If you push it off of your table, it is no longer at rest. If you never push it off of your table, it would remain at rest until acted upon by a force. The law of inertia also states that an object in motion will remain in motion unless acted upon by an outside force. Take, for instance, my blue friend here. He's on his skateboard. He's been skating all day, having the best time. Something stops him. It's a rock. If that rock was not there, he would continue moving. Okay, so the only reason that he stopped moving is because his skateboard was acted upon by an outside force. So, the big thing that we need to get is, how does inertia and gravity work together? Well, inertia helps to lead planets to follow a straight path, right? An object in motion will remain in motion. If we think back to the Big Bang, to that sudden expansion, if there's nothing to stop those planets and things being formed from moving, it's going to continue to move because of inertia. So inertia is going to keep the planets moving. And gravity from the sun is what pulls the planets inward to orbit. Okay, so these forces together, inertia and gravity, work together to keep planets from flying off into space. Let's look at some examples. This is an artist's interpretation of the planets. Okay, so what we see here is they're moving. Now notice that Uranus and Neptune are not moving because their orbit does take a very long time. The planets are moving. They're orbiting the sun. So the sun's gravity is pulling the planets in. Notice when Saturn and Jupiter kind of line up with each other and all of the planets line up, what do you notice? They kind of slow down a little bit. They're very close to one another. So their gravity is also acting on other planets as well. Okay, so we have my friend here, Bob. What does he need to survive? He's driving his car. He's in motion. Okay, and he hits a wall and he flies out. Okay, hopefully the thing you said that he needs is a seat belt. Okay, so inertia and gravity is working here as well. Inertia, the car is moving and it will continue moving unless acted upon by an outside force. Now that outside force is the brick wall. Well, not only is the car moving, but Bob is also moving. Okay, and so Bob is going to also, just because the car stops, Bob is also going to continue to be in motion unless acted upon by an outside force, which would have been his seatbelt, right? If you're ever in the car and your mom or dad needs to slam the brakes on because maybe someone's not doing what they're supposed to be doing and you jerk forward a little bit against your seatbelt, right? So that's inertia happening. You were in motion as well. Okay, another example. Okay, our pet hamster, right? He's enjoying his time on the wheel, and then he kind of gets ahead of himself and he gets taken over. So what happens when a hamster stops running? Okay, so he's moving, and then he stops moving, but he's going to stay in motion unless acted on by an outside force. The outside force would be the owner stopping the wheel, therefore helping to stop the pet hamster. And one last example of gravity and inertia working together. Okay, remember, inertia is an object in motion will remain in motion unless acted upon by an outside force. Okay, remember to answer your essential questions.